Ever play a game where something just feels off? Maybe you can't quite put your finger on it. A slight sluggishness, a tiny delay. That subtle difference in responsiveness can kill the immersion. Today, we're not just looking at specs. We're tracing the actual pathways your pixel stream takes on AWS and CoreWeave. We'll show you how fundamental differences in their network architecture can create that feels different experience, and why a more direct path often translates to a dramatically smoother, more natural interaction. Today, we analyze AWS and CoreWeave, focusing on the critical engineering factors that directly influence your streaming performance and deployment workflow, based on our direct experience and observed platform behaviors. On AWS G4DN instances, the GPU resources are managed through a virtualization layer. This architectural choice introduces a level of abstraction between your Unreal Engine application and the physical NVIDIA T4 GPU. CoreWeave, conversely, provides direct access to physical GPUs, eliminating this intermediary layer and its potential resource management implications. You know what's crazy? Most developers never really see these fundamental differences in how the GPU is accessed until they're deep into a project and hitting performance walls. If you want these kinds of actionable insights delivered every week, just tap subscribe. It's free, and honestly, understanding this stuff can save you a ton of headaches down the line. The network path taken by your pixel stream can influence latency. Our observations suggest that traffic flow patterns differ between AWS and CoreWeave. The distinct requirements for turn server configuration on each platform indicate fundamental differences in their network architectures and how they handle external connections for pixel streaming. Examining the reported dedicated video memory on each platform reveals a notable point. The usable dedicated video memory reported within the AWS environment for the virtualized GPU may differ from the total dedicated memory reported for the physical GPU on CoreWeave. This difference in reported availability is a factor to consider for memory-intensive pixel streaming workloads. This difference in reported VRAM is something I'm always keeping an eye on. I'm curious, are you seeing similar memory reporting in your own cloud tests? Drop a comment below with what you're finding. Our observations indicate a noticeable difference in the startup duration between AWS and CoreWeave, which can impact the speed of development and deployment cycles. Subscribe for more objective technical analysis. Gain a deeper understanding of the engineering factors in cloud pixel streaming.